Distance cannot be negative. Distance is not negative, but direction can be negative. So the result of subtraction is a number and a direction.
Welcome to Tier 1 Interventions Podcast, where we help you strengthen your core classroom instruction so every student has the chance to thrive, even those students that need additional instruction. I'm Cheri Dotterer, and today Jonily and I are diving into the second of 3 math rules that never expire: subtraction. This is one of my favorite rules, not just about the math. It's about how the brain thinks. And you'll hear Jonily use subtraction across all grade levels and jump into tips on how to make learning stick with these brain-based strategies, movement, and multisensory engagement. Whether you teach kindergarten or high school, whether you're an occupational therapist, let's learn how we can change the way we instruct mathematics and help kids make subtraction stick.
Hello and welcome to Tier 1 Interventions Podcast, where we talk about strengthening your core classroom. That is, I'm your host, Jay-Z, Jonily Zupancic, your main mathineer, math specialist, math coach, math leader. And at Tier 1 Interventions Podcast, we share tips, tricks, techniques, and strategies to enhance your Tier 1 core general classroom. This reduces the number of students that need Tier 2 and Tier 3 pullout. With a strong core, Tier 2, Tier 3, no more. Just a little joke. Not that we want to eliminate those small group pullouts, but we want our Tier 1 core regular classroom, specifically for mathematics, to be accessible for every student, no matter the ability or disability. We teach instructional and facilitation strategies that are going to increase learning, memory, and retention of content, specifically with mathematics. We want to share strategies with you to improve number sense, thinking, reasoning, and sense making. Today's focus is going to be on rule number 2 of 3 math rules that never expire. These rules are transferable from preschool through high school, no matter what the number is.
Hey, Cheri here. When we teach a concept that works at every level, from preschool through high school, we're giving students the brain pattern that doesn't have to be unlearned later. That consistency frees up working memory so we can focus on reasoning and sense making and remembering at any stage and building rather than tearing apart.
Some math rules that expire are things like when subtracting, you can't get a smaller number. That's only true with certain numbers. We need a rule that we can teach consistently from progression from preschool through high school, that the rule and the strategy is not going to change. These specific rules, and there are 3 big ones, are the rules that never expire and make high impact, powerful results in improving number sense for our students. Rule number 1 is division is counting. Rule number 2 is subtraction is distance. Rule number 3 is multiplication is rectangle. No matter what the numbers are, these rules and processes never expire. They are transferred from grade level to grade level as we evolve and create more complexity in numbers. Today, we're going to focus on rule number 2, subtraction is distance. In the previous episode of Subtraction is Distance, which was aired on February 18th, 2025, called Hidden Math Patterns That Make Subtraction Easy for Everyone, The introductory version of the 3 math rules that never expire, specifically with subtraction, was released on that podcast episode. So look that up if you want to start at the introduction. Today, we are going to do an extension of that introduction, and we are still going to follow the subtraction is distance cycles A through Z. But today, particularly, we're going to focus on 2 of the extended cycles. These cycles and these numbers are appropriate for any and all grade levels, and the thoughts and ideas and strategies that I share are absolutely essential for improving number sense in your school. Remember, number sense is an innate, intuitive understanding of the size of number. Another word for size is magnitude, understanding the value of number. And for subtraction, the question is, how far apart are these 2 numbers? Subtraction is distance, subtraction is range. And yes, subtraction are other things, but some of those other things are not transferable, especially when we get to negative numbers. So if we want to build consistency and progressions of improving number sense from preschool through high school, this rule number 2, subtraction is distance, is the strategy and technique to do just that. We are going to focus on 2 subtraction cycles today, F and P. In the previous podcast titled Hidden Math Patterns That Make Subtraction Easy from February 18th, 2025, we focused on cycle A, which is the introduction to subtraction cycles. In the show notes, you will get a copy of this notes version that will accompany today's podcast. If you are listening to this podcast audio only, I'm going to be as clear and explicit as possible, telling you about what's on the screen. However, to catch a glimpse of what I'm writing at the same time that I'm talking, you can visit us on YouTube at Tier 1 Intervention Podcasts. Subtraction cycles F and P are as follows. Cycle F, these are the 4 problems that we are going to model today. 8 minus 3, 3 minus 8, 1012 minus 995, and negative 3 minus negative 8. Cycle P, 71 minus 38, 38 minus 71, 7.25 minus 3.5, and negative 13 minus negative 7. As we look through some of these examples, you're going to see how this transferable strategy can be used with any number. This gives access to negative numbers earlier in the grades with this one strategy. We don't have to change our strategy or technique when we subtract when we use this method. Again, this isn't the only method. There are other methods to use for different numbers that are procedural. Procedural focuses on answer getting and efficiency and accuracy. Improving number sense is negated when we focus on efficiency and accuracy. However, improving number sense is necessary for accuracy and fluency and efficiency to be improved. That all sounds counterintuitive, but all of them are necessary for overall math achievement. So what does it mean to have subtraction as distance? Subtraction as distance means in a problem, the second number is my starting point on a number line, and I'm going to find the distance between that starting number and the first number in the subtraction. Technically, this subtraction symbol, if I put arrows on either end of the actual subtraction symbol, that shows that I'm looking at a number line, and the subtraction symbol, in the depth of its meaning, is how far apart are these 2 numbers. If I place these 2 numbers on the number line and I go from the second number to the first number, what is the distance? What is the range? How far apart? Now, as you can see here, my second number is 3, so I'm going to put 3 on the number line. My first number is 8. I'm going to put 8 on the number line. So I'm going to start at 3, and I'm going to go to 8, and I have to figure out how far apart those numbers are. Now, for these numbers and for some students, I may have to put tick marks to say, okay, here's 4, 5, 6, 7, not drawn to scale, obviously, so that then we can circle or mark the spaces. Kids like to count the tick marks, but we really need to count the number of jumps or the number of spaces from 3 to 8 as we are teaching distance and measurement. This is a good intervention for that as well, but also enhancing work on a number line. As I've talked in previous sessions, one of our interventions for number line is to create that rectangle bar model over top of the number line and extend the tick marks so kids can see these spaces. That's a little less abstract and much more visual representational than the abstract number line itself. So the distance from 3 to 8 is 5 units. And because we went to the right, we have a result of positive 5. If we follow the same strategy for this second problem, now our starting number is 8 on the number line. As a matter of fact, I could have used the same number line, but I'm going to draw a different one. My starting number is 8, so I'm going to put 8 on the number line. And I'm going to move to 3. I'll mark 3 on the number line. Now keep in mind, already I know that I'm moving in the left direction. My result's going to be negative. Distance cannot be negative. Distance is not negative, but direction can be negative. So the result of subtraction is a number and a direction.
Hey, Cheri cutting in here again. Breaking distances into chunks is actually how the brain naturally processes magnitude. It reduces cognitive load and letting the prefrontal cortex, that's this part right up front here, hold smaller and manageable pieces, making mental math faster and less stressful.
So if I start at 8 and go to 3, now what's super cool is subtraction is not commutative, meaning if I change the order, I don't get the same exact answer, but I do get an answer that shares a relationship. So if the distance between 3 and 8 is 5, the distance between 8 and 3 is still 5. The distance doesn't change, but the direction changes, and that's why my overall result is negative 5. When we explore subtraction as distance, we are actually teaching many more standards than just subtraction. That's why this improves overall math achievement, because we're looking at number line, measurement, distance, range. We're also looking at counting, which improves number sense. Estimation, is the distance going to be a lot or a little? Like, let's look at this next one. Grab a different color here. The next one is 1012 minus 995. 995 is our starting number. So if I sketch a number line and I mark 995 on my number line, the number that I'm going to is 1012. Now, using this strategy and technique and this thinking exercise, and really what this is a thinking exercise, it's not a procedure for answer getting and accuracy. That is important, but that's a different exercise. This exercise is a thinking exercise. It's a minds-on exercise. It shapes the brain differently than working and mimicking a procedure step by step. This actually increases problem solving and critical thinking skills because students are constantly figuring out. It also improves number sense because I'm actually physically seeing values of number through distance.
Hey everybody, it's Cheri again. If you're loving these strategies and you want to join our Mastery Math Method Masterclass, we hold this hour-long event once a month, and we'd love to have you join. What we talk about there is how to improve your math skills in 10 days. Can you imagine 10 days? Whether you're a math teacher or an occupational therapist, you can see exactly how to shift teaching so that every student, no matter their starting point, can master core math concepts and reserve your seat today. And go over to disabilitylabs.com/calendar to check out the next event.
I'm practicing my counting techniques, which increases rate and function. So all of the standards depend on this strategy and technique for subtraction. So if I typically look at this, in typical traditional procedure, I would stack and subtract. 1012, I'd put 995 underneath. I'd do a lot of borrowing, blah, blah, blah. In that procedure, there still is a lot of room for error, and it doesn't improve conceptual cognitive function. So with this process, not only is there a little bit of room for error, but I actually can estimate better and improve my conceptual cognitive function. So I'm really working the brain and exercising the brain. There's brain growth that is happening through just thinking about this through this distance technique. So if I stack and subtract, there is room for error, but also in looking at those two numbers on top of each other, it still doesn't trigger to me distance, how far apart. So I can ignore the value of those numbers, which means I'm not practicing a good estimation prior to solving the problem. Here, where I'm placing the numbers forces me to think about the value of the number, where it's going to be placed. And then as I place this, oh, you know what? I think 1000 might be there because I'm thinking 1000 closer to 995, a little further away to 1012, but really, in all honesty, neither of those numbers are too far from 1000. So that thought process, rather than a procedure, is what is exercising and shaping and growing the mind to have a better understanding of number for students. So when we look at this, we can see subtraction is distance. I start at 995. I need to go to 1012, which is to the right. So my direction is positive. Distance is always positive, but I can break this distance into we're 5 away here and we're 12 away here. So the total distance difference is a combination of 5 and 12. If I relate this to 1000, lots of ways to think about that. We can use manipulatives, we can use bar models, concrete, paper strips, lots of instructional strategies to use. But the point is for students to engage in this experience of figuring out the distance. How far apart are these two numbers? So 5 and 12, 17, the distance is 17. If I switch this around, 995 minus 1012, I start at 1012, I go to 995, the distance is still 17. The result is negative because I moved to the left direction. Now, you might be saying, again, why don't we just teach procedures for these? The issue is the procedures for single digit numbers, multi-digit numbers, and then negative numbers are all different types of thinking. We teach different strategies, and that's fine. We don't have to stop doing that. But the one strategy that works for every single number is looking at subtraction as distance. Let's look at this example. So in this example, my second number is -8, and I'm going to go to -3. Now, typically what happens in some of these problems is if I have an example like -3 minus +8, kids will frequently ask, is that second number, is it an 8 or is it a -8? And typically the teacher response is, well, it's both. Technically, let's look at this technically. Technically, remember when we make that subtraction symbol the representation of a number line, so I'm going to put arrows on the left and right end of the subtraction symbol. Technically, right here as this appears, this is +8. So I have to mark this at +8 on the number line. So if this is +8 on the number line, because it's +8 right now, but I know what you mean, that subtraction can change to addition, which makes it a -8. But right now, it's subtracting a +8. So that means I'm starting at 8, and then I'm going to -3. I'm starting at 8, and I'm going to land on -3. So right away, I'm moving in the left direction. And I can use these number lines vertically also, up and down. And I interchange that constantly. So if I'm starting at 8 and going to -3, I'm moving in the left direction. So direction is going to be represented by negative. Distance is always positive. So now if I go from 8, let's say to 0, that's a distance of 8. And then we have from 0 to -3, a distance of 3. There's a distance of 11. The distance is 11. The direction is negative. So when we look at this in that way, the same strategy, technique, and thinking that we used with the previous examples, we end up doing the same exact thing no matter what the number is. We're not changing the strategy or technique because now we have different types of numbers. And we can negate that misconception that this is both a -8 and a +8. As it stands there, it is a +8. So we oftentimes, with our language and how we're responding to students, are giving them misconceptions, and that is what's causing them a number of errors and inefficiencies in calculation and computation. So now let's look at the one that was actually the example that was actually here, which is -3 minus -8. And again, that subtraction symbol, if I put arrows on each side, we can clearly see that my second number is -8. And I'm going to go to my first number, which is -3. And then I can mark 0 just for conceptual, just framework, really. So now I'm going from -8 to -3. So my result, my direction is positive. Distance is going to be positive. So now -7, -6, -5, -4, -3. How many hops? How many spaces? And again, an intervention for students to have better access to this is to create the bar model over top of the number line. And instead of tick marks, create dividing up a bar so that we can clearly see there's 1, 2, 3, 4, 5 spaces. As we look at cycle P, same thing with all of these, but the one thing I want to point out is this example. In some of the cycles, we add in decimal numbers and fraction numbers as well. That's why we're giving you cycle F and cycle P today. There's importance in larger numbers, multi-digit numbers, also importance in decimal numbers and fraction numbers. But let's see how this works. If I have a number line and my second number is, if I put my number line here, there's not going to be any confusion. That's a +3.5. So if I put my 3.5 here and my land on number, my distance from 3.5 to 7.25, and you can see this gets a little more complicated, but again, I'm not looking for efficiency and accuracy. I'm looking for a thinking exercise that's going to contextualize and conceptualize subtraction being distance so that I can improve my estimation, my counting skills, which estimation and counting are fundamental for number sense. So if you have students that have weak number sense, yes, they're going to struggle with these thinking exercises, but the more exercises we have them do with this, the better their sense of numbers is going to be. So here, this is going to be a little tricky because it's okay, 3.5. Where's 3? Where's 4? Maybe this is 3. Maybe this is 4. So there's a little playing around here with how much this is. Oh, but wait a minute. I know 7 is here. Actually, 7 is going to be a little closer to that line. I didn't draw it to scale. We can have those discussions. We can actually do draft 2 with 3.5 and 7.25. So 7 is going to be closer to 7.25, but 4 is going to be further. Like we can start to scale it a little bit better. And modeling this for students and then having them work independently on it is going to be the key to engaging them in deep thinking, reasoning, and sense making. It is not going to be easy. It's not about accuracy and efficiency. It's about playing with it so that they can figure it out and they can start to understand value, size, magnitude. Magnitude meaning how large and small numbers are and where numbers are on the number line. And in this case, how far apart numbers are. So once we have decimals and fractions in the mix, the thinking exercise extends. We want to give kids lots of time to think about this, lots of time to play with it. And then what I might do is I might say, you know what? We're not going to finish this today. We're not going to finish this today. We're going to come back to this another day, because thinking exercises, if we finish thinking exercises and we confirm.
Did you know that letting things linger actually improves thinking skills? By letting things linger, you're letting the brain process what you've just taught. Rather than give it the answer and let it stop thinking, don't give them the answer. Let it think. You'd be surprised how many kids will come back to you 2 or 3 days later and say, "Hey, Mrs. or Mr., I think I figured out the answer to that thing that we were talking about on Monday." And you'll be going, "Why? How are they thinking about this 2 or 3 days later?" Their brain's been processing it ever since you left it linger.
Or deny accuracy and efficiency, then the brain stops thinking about the thinking exercise. However, if we don't confirm or deny accuracies, we gather lots of answers, we let the conclusion linger and come back to it maybe 3 days later, a week later, or 2 weeks later, the subconscious mind automatically continues to think about it because there's this cognitive dissonance. There's not been a completion or a closure. What we want in mathematics, we want the brain to work overtime. Too often in our math classes, we have this, and Dan Meyer said it beautifully a number of years ago, we have this sitcom approach to mathematics where you watch this show for 30 or 40 minutes and we expect everything to be wrapped up at the end of that time, and we're rushing to get through and we're not allowing students to process and have cognitive subconscious thinking that they're not even aware of. So we're limiting that. And so the brain stops working because there's no dissonance, there's no conflict because everything has been wrapped up. The only conflict is some of our students that have slower processing or didn't get enough time to think, they stop thinking during math classes because they know other people are going to think for them and other people are going to finish for them. So there's an implication to the way that we facilitate. So oftentimes I will let the answer, the accurate answer, linger on this and come back to it 2 or 3 times. And that's one of the reasons for the cycle as well. These are thinking exercises to improve number sense. We use these subtraction cycles, and by using those subtraction cycles, we can improve number sense and also increase motivation, focus, engagement, reasoning, and sense making. And those are the culture of math classrooms that we're trying to create to produce amazing Mathaniers. Today was the extended version of a previous podcast that was released on February 18th, 2025, titled Hidden Math Patterns That Make Subtraction Easy for Everyone. That podcast episode was the intro version to today's extended version, the part 2 version. But this is also as part of a series of podcasts that are 3 math rules that never expire. Rule number 1, division is counting. Rule number 2, subtraction is distance. And rule number 3, multiplication is rectangle. I was your host today, Miss JZ, Jonily Zupancic, here with Tier 1 Interventions Podcast.
Hey, thanks for joining us today for this episode of Tier 1 Interventions. If you found today's strategies helpful, imagine what your students could achieve if every math lesson clicked this way. Make sure you subscribe to us and send us a comment in the show notes. Send us a comment and let us know what you thought of this episode. Don't forget to grab your spot at Mastery Math Method Masterclass, where you can learn how to make your math stick in 10 days. Go to disabilitylabs.com/calendar to register. Until the next time, go be awesome, go be brilliant. You were put here for such a time as this. Make Tier 1 strong so that every student can thrive.